Okay, welcome to AP Calculus. This is a quick video to recap Chapter 4. This will be quick because there are two kinds of things you need to know from Chapter 4. Thing one is derivatives of particular functions, and thing two is processes and when to use them. So what derivatives do you need to know? We have arcsine of x. We have arcsecant of, whoops, why did I write sine again? No idea. Arcsecant of x, and we have arctangent of x. We know, where we discovered that this is 1 over the square root of 1 minus x squared, that this is 1 over absolute x times the square root of x squared minus 1. And that this is 1 over 1 plus x squared. We also know that the derivative of arc cosine, by the way, I should have written derivative on every single one of these. Sorry about that. The derivative of arc cosine is just the negative derivative of arc sine. The derivative of arc cosecant is the negative derivative of arc secant, and the derivative of arc cotangent is just the negative derivative of arc tangent. So I'm not even going to write them all out again, but there you go. Here, well, I could do that for you. Boom. And that way you only have to remember 3 of them, and then just remember that the others are negatives. 4 more derivatives. The derivative of e to the power of x is in fact itself. The derivative of natural log of x is 1 over x. And then we can generalize these as the derivative of some other number to the x is the natural log of that number times itself. And the derivative of log base a of x is 1 over the natural log of a times 1 over x. So there you go, 10 derivatives that we discovered throughout the course of Chapter 4. You should especially know the bottom 4, and it doesn't hurt to know the top 6, or at least know where to look them up when you need them. Okay, so let's go to processes. I will start with chain rule. The chain rule says that if I have some function that is a composite function, the derivative of f of g of x, I'm going to, and I like to color code, as you will know if you had been watching all my videos. This is the inner function. This is the outer function. And the derivative of this is always just the outer, and I will f prime of, and I've got to remember I want to leave that inner function alone, times the derivative of the inner function. And there can be as many layers of inner outer as you need. You could have inner, middle 1, middle 2, middle 3, middle 4. Start at the innermost thing that you would do if you were doing a calculation. Make a list working your way outwards, and then take the derivative in reverse order. Just do not forget this part right here, that you have to put the inner function back into your first derivative. Okay, so there's chain rule. You can go back through your notes and the previous videos, lots and lots of examples. Make sure you know how to use the chain rule. Implicit differentiation. Implicit differentiation is useful when we have a situation where we cannot write y equals some function of x. Instead, we have some function of x and y. And the way implicit differentiation works is that when we get to the part that is a function of y, we take the derivative by taking the derivative of that function and then using the chain rule to multiply that by dy dx. So an example would be xy plus y equals x squared. And we would say that, well, product rule, this is u, this is v. We've got u dv. Let's make that a y squared just for fun. Plus v du plus, now the implicit differentiation here says that the derivative of this is 2y, the derivative of y squared, times the derivative of y. And then on the other side, we've just got 2x. And so now we get all the dy dx on one side and factor. I've got x plus 2y equals 2x minus y, and then solve for dy dx. So the key thing about this is to just recognize that this is an extension of the chain rule with y as some function of x. We just don't happen to know what the function of x is, so it makes it more difficult. Okay, that's implicit differentiation. Let's talk about logarithmic differentiation. We use logarithmic differentiation when we have y equals some function raised to the power of another function. And the idea here is that if we take the log of both sides, and I'll use natural log because it's just simpler to write, it doesn't really matter, is equal to g of x times the log of f of x. Take the natural log of that, and then we can move the power out front. And then we can use implicit differentiation on this side. This will be 1 over y times the derivative of y. And we'll use the product rule on this side. And so we've got g of x is u, natural log of f of x is v, and you would work your way through it. I'm not going to do the whole example here, but you would just work your way through using the product rule. And of course, don't forget the chain rule when you get to natural log of f of x, with, of course, natural log being the outer function, f of x being the inner. There's a little hint for you. All right, so that's our third process. A couple quick reminders. We talked about rational functions. Anytime you have a rational function, write it as a power, use the power rule. So the square root of x is x to the 1/2. So if I need to take the derivative of the square root of x, that's the same as the derivative of x to the 1/2. And the power rule says that's 1/2 x to the 1/2 minus 1. And of course, I'm sure you remember that the nth root of x is x to the 1 over n, and that x to the m over n is the nth root to the mth power. Good. And finally, last thing for this quick video, inverse, I forgot an R there, inverse functions. And I'm going to post up a separate video that I'm going to clip out of a discussion we had in class yesterday about finding the derivative of an inverse function. Suffice it to say that if f of x has point AB, then f inverse of x has point BA, and the derivative of the inverse at B is equal to 1 over the derivative of the function at A. Reciprocal? Switch the points. There you go. There's how you find the derivative of an inverse function. So generally what you'll have to do, you'll be given some x value A. You have to calculate B in order to know where the rest of the point is. you have to calculate the derivative of the original function f at point A, and then the derivative of the inverse at B will just be the reciprocal of that value. And like I say, I'm going to post up a separate video on this. It's part of the full video that I did on that section, but I've had some questions, and it can be a complicating concept. So there'll be a short, I think we had a 5 or 10 minute discussion in class yesterday, and I'll go ahead and post that up for you a little bit later. All right, guys, that's chapter 4. That's everything. If you need to know, if you know all of this and you know the stuff from the previous chapters, you'll have no problems with chapter 4 and the assessment that's coming up. And if you're not in my class, hopefully you'll learn something anyway. Thanks. Have a great day.